everybody. Today we're going to talk about ANOVAs in Jamovi. So I went ahead and loaded our data, but I did not fix all of the variables. I figured I would do that as a little recap. In order to understand what this data set is, I'll give you a little background. We have roughly 41 participants, and they were keeping track of how much water they drank on day 1, how much water they drank on day 2, and how much water they drank on day 3. They also kept track of their activity levels on those 3 days, which were then calculated, and they were put in a category of either low activity, medium activity, or high activity. And this last column we have here is an average of the water they drank day 1, day 2, and day 3. So I'm going to go ahead and update our variables. I'm going to go ahead and that's day 1 water, and it is a categorical or continuous, I'm sorry, not a categorical, it is a continuous variable. Well, I'm glad I'm helping you. Steer you right in the wrong direction. Then we have day 2 water. And it is also continuous. And we have day 3 water, which is continuous. We have our variable of activity level, and that is ordinal because we have low, medium, or high activity, so it is in order. It is ranked. And for our last variable, it is our average water consumption. Great. Now we have all of our variables set. So we want to run an ANOVA because we want to answer the question of whether or not activity levels impact our average water consumption or intake. So I'm going to have my average water consumption as the dependent variable, and our independent variable would be activity levels. This would be a between subjects ANOVA because participants are contributing to only one of the conditions. They are either in the category of low activity, or they are in the category of medium activity, or the category of high activity. They're not in multiple categories. Before we do this, however, we want to know what our descriptives are for these categories. So let's go up here to Exploration and Descriptives. My variable that I'm interested in is the amount of water, but I want it to be split by the activity level group. And when I look at my statistics, I personally always look over at missing. I see nothing's missing here, so I'm just going to get rid of that. I don't need it. I definitely don't need median. I want my mean because I have continuous data, so I want mean for my central tendency. And for my dispersion, I want standard deviation. I'm going to go ahead and get rid of minimum and maximum. And this makes the chart a little bit more workable for me. Now I can see here that, for instance, medium activity has a count of 19, and their average daily water intake is 55.8 with a standard deviation of 18.9, and so on and so forth. So I'm going to come up here now to ANOVA. I'm going to go down to the ANOVA. So we're going to put our average into our dependent variable box and our activity level into the fixed factors box. I also want to be sure to get the effect size, which is going to be the eta squared. And we can see that appear right here. And just so everyone is aware, that is not a little n, that's actually the Greek letter of eta. I can see also that I have, right now I'm looking at what looks or appears to be a significant F statistic because my p-value is below 0.05. However, I want to make sure I haven't broken any assumptions, so I'm going to run a homogeneity test. And when I look at the homogeneity test, I can see here that I have not violated an assumption, that my p-value is above 0.05, which means I have not violated my Levene's test or homogeneity of variance test. So that is good news. I also then want to run a post hoc test, which I'm going to find right here, and I want to run that on activity level. The default for the post hoc test is going to be the Tukey. However, we are going to want to run the Sheffey. And I typically add the Sheffey when I know that my counts are very different between the different groups. So I had, I think, 14 in one and 8 in one and 19 in one. So because of that, I'm going to want to look at the Sheffey versus the Tukey. What is it I'm looking at? Well, what I see here is that my p-value is significant. So I have a significant difference for the ANOVA. There's a difference in the groups, in the means of the groups, which means that low activity, medium activity, and high activity, somewhere in there, some of those groups or all of those groups are different from each other. What I want to look at is my post hoc test, and the post hoc test is going to tell us whether it's medium activity to low activity. If you follow right along this top line, we can look to see the Sheffey is 0.203, so that is not one of the groups that is different than each other. So medium activity and low activity are not significantly different from each other. We can look at medium activity to high activity by coming right down here to the second line and going across. And the result is our p-value for our Sheffey test is 0.089, which again is above 0.05, so it is not, they are not significantly different from each other. The last one we want to look at is the low activity to the high activity, and we're going to come all the way across to our p for Sheffey, and we see that it is 0.004, which means that is significant. So our low activity to high activity are significantly different from each other. However, our medium activity is not significantly different from low activity or from high activity, or different from high activity. We're going to come back to this when we're writing up our results, but these are really important findings. Now let's go back and look at our data one more time, because what I'm thinking is it would be also interesting to understand or find out if there's a difference between day 1, day 2, and day 3. Maybe the difference in the water intake that a person has, depending upon what day it is. So the research question would be, does day have an impact on amount of water consumed by a person? In order to do this, we again would run an ANOVA, but this time it would be actually a repeated measures ANOVA, because the participants are contributing into each condition. So participant 17 is contributing into day 1, day 2, and day 3, or the same goes for all participants. So I'm going to go to repeated measures ANOVA, and my factor is going to be day, and I'm interested in day 1, day 2, and day 3. And you can see they've appeared down here, day 1, day 2, day 3. So I'm going to drag my variable for day 1, day 2, and day 3. Now I'm not interested in activity level because I'm not trying to divide them by activity level. I'm just curious as to whether or not the day can impact the amount of water that someone consumes. And again, I want to get the eta squared. It's down here. We also want to check our assumptions. And when we're running repeated measures ANOVA, the important assumption that we want to check is for sphericity. So I'm going to click on sphericity. I'm going to look at my test of sphericity, which is my Machlis, and I can see my p-value for my Machlis is not below 0.05. If this were below 0.05, we would have broken the assumption. Here we have not broken the assumption, so we are okay. However, if we had broken the assumption, we would want to run a greenhouse geyser test so that we could also get the results for greenhouse geyser. Let me show you what I mean by that. If the Machlis was had a p-value of below 0.05, that meant that we were breaking the test of sphericity. And I would click over here on greenhouse geyser, and up here at top in my within subjects effects box, my greenhouse geyser results would appear. Now, as we can see when we look at the greenhouse geyser, what's changed is the p-value has changed a little bit, very slightly, and most of the change, the F statistic has stayed the same. Most of the change has happened within our degrees of freedom. We've changed from a 280 to a 1.85, 74.05. So this is where we find that it's become more stringent. But because in this test we did not break assumptions, we do not need the greenhouse geyser. So I will get that out of our way. And we're going to look at repeated measures ANOVA that we ran, or within subjects. We can see here that the p-value is not significant. This is above 0.05. What is this telling us? Well, this is telling us that the day did not have an impact on how much water someone drank. Therefore, the eta squared, that is not in effect because there wasn't actually a difference. And we don't need to run our post hoc test because, again, there's no differences in the groups. So we would report this just as is and say that it was not significant, that there were no differences between the groups based on day and the amount of water consumption that each group had based on the day. Let's spend a minute figuring out how we want to write this up. Okay, when it comes time to write this up, we want to be sure that we've got all the important pieces. Now normally this would be double spaced, size 12, and I've got it like size 18 single space, but that's just so we can see it on the video. When writing it up, it's very important that we identify the independent variable, the dependent variable, the test that's run. We want our inferential results. We want our descriptive results. We also want to talk about our effect size and then whether or not we would reject or fail to reject the null hypotheses. And all of this needs to go into our results section. If you follow along, I can show you some of the most common ways of writing these results in APA format. The between subjects ANOVA was run with activity levels, low, medium, high, as our independent variable and daily average water consumption as our dependent variable. Results indicated there was a significant impact from activity level condition on the daily average water one consumed. And I have the inferential F statistic. Sheffi post hoc analysis indicates that water consumption was significantly higher for high activity level participants than low activity level participants. However, medium activity level participants do not significantly differ in their average water consumption from either high activity or low activity level participants. Eta squared explains that effect from activity level can explain roughly 25% of the difference in the water consumption. This research would reject the null hypothesis that activity level does not impact daily water consumption. I'm going to break this down for you. So we have what type of ANOVA we ran, a between subjects ANOVA. We also talk about our independent and dependent variable right here. The next thing we report is our F statistic, or our inferential statistic. Now, it's very important that we use the word significant because an inferential statistic is either significant or it is not significant. And this actually was significant. Why is it significant? Because we had a p-value of 0.04. In my F statistic, I have my degrees of freedom, which we can find right here. We have the actual F statistic, which you find right here. We have the p-value, which we find right here. And we have our eta squared, which we find right here. You'll notice when reporting the p-value and the eta squared that I do not use the leading zero. In APA, we don't use a leading zero on a number that does not go above 1. So if the number can only be between 0 and 1, we do not have a leading zero. Because it was significant, we ran a post hoc. Our post hoc, we want to always discuss which one we're interpreting. We're interpreting the Sheffey, not the Tukey. So I write that Sheffey post hoc analysis indicated that water consumption was significantly higher for high activity levels, and so on. The important thing, and I did not do this yet because I wanted to show you what I do. The important thing is there's two pieces to this sentence that we're writing right here. There are two very important things when we're reporting our post hoc analysis. Number one, we want to get conceptually what's happening, what the differences in the groups are. Number two, we also want to have our descriptive results sort of interwoven into this. And I'll show you what I mean. So right here, we've talked about that higher activity levels was significantly different than low, which is true, and that medium was not different than low and medium was not different than high. So what am I going to do? I'm going to go right in here. High activity level participants, then low activity level participants. However, medium activity level participants. So we have three groups. We have high activity level participants, low activity level participants, and medium activity level participants. For our high activity participants, our N was 8. Our mean was 77.5. And our standard deviation, 32.4. Again, I'm writing all of this in APA, so I want to go in and italicize. I use a lowercase n, not an uppercase n, because I'm only talking about a portion of the group. These are all portions of the total 41. And then I will just go through and do the same thing for low level and medium activity level participants. And voila, I now have my descriptives and the conceptual framing of what groups are different than other groups. I want to finish this up by talking about my eta squared. And eta squared can be interpreted as such that this 0.25 means roughly 25% of the differences in the groups can be explained by the independent variable that we're looking at. And then I'm going to go ahead, because it was significant, I will reject the null hypothesis for the activity level. Now, in writing up our second one, the repeated measures ANOVA was run with day as the independent variable and water consumption as the dependent variable. Results indicate that the day did not have a significant impact on water consumption. Whoops. I don't want to forget to italicize. I'm italicize all of my Latin abbreviations. So I've found my F. From my repeated measures ANOVA. Here's my F score, my p-value. I don't need my eta squared because it wasn't significant. Remember, my p-value was above 0.05. Here are my degrees of freedom right here. So I've got my F with my degrees of freedom equals 1.88. My F value was 1.88. My p-value equaled 1.159. No post, whoops, I should say post hoc. No post hoc was needed because there were no significant differences between day 1, day 2, and day 3. And in here I have put my descriptive statistics. I have not included an effect size. There would be no effect because it was not significant. And I have decided to fail to reject the null hypothesis that there is no impact. You'll notice that I don't have the count in here. All of the counts were the same. The count was 41, but I can actually put that up here with an uppercase N because they were all the same. Whereas these were all different, these are all subgroups, so I have a lowercase n, and I want to have them within each group. In this one, they were all the same count for the groups. That was the total population. And I hope this video can help you with ANOVAs. Have a great day. Bye-bye.